Welcome. In this video we are going to look at current in series and parallel circuits. This is my kind of worksheet that I'm going to be working through with the real components over here. So if you would like to take a moment to either make your own version of this or just follow it through, that's absolutely fine. So what I need is my battery pack for each one, and I've got that here. You note the positive is on the left, negative on the right, positive on the left, negative on the right, even though the right is upside down, that's not important. Other things I'm going to need are some bulbs. I've got those at the ready, I've got some wires ready, and I need my ammeter, which is here. Now what you'll see is my ammeter is going to be, it's the same ammeter in multiple places. So when I make the circuit, you'll see I'm going to move it around. Now to start this off, what I'm going to do is connect up my circuit. So the way I do that, I'm going to physically place my objects around like they are in the circuit. So I've got my battery there, I've got my ammeter there, I've got my bulb there. This ammeter will need to move over there in a minute. So at the moment, that's fine. Now we're going from the positive side to the ammeter. That's what I'm going to do. I'm going to go from the positive side of the battery to the positive side of the ammeter. I'm going to turn the ammeter on. At this point, it doesn't matter what colour wires you use because they're all the same. It just helps with the direction of sort of seeing how the circuit's connected. So this next connection is going from the ammeter into the bulb, and now I need to connect the bulb. See, the ammeter's not really there, but I'm going to connect it directly to the battery here. Now, one thing you need to know about ammeters, they watch the circuit. They look at what's going on. They detect this thing called current that's going through them, but they don't actually contribute directly to it. So if the ammeter isn't there, it doesn't change the circuit properties in any way. All it means is we can't read the current at that point, at that moment in time. So it's fine for you to just put a wire straight through it, as we're going to do here, and the bulb turns on. So as you can see, it's all connected up as we have with A1 here, where the ammeter is, and that is reading 0.364 amps. Okay, and I don't need to write the amps because I've got it in the column up there. As you see, it's just changed slightly because we're dealing with real components that are not the most expensive, not the most amazing components. They will vary a little bit with the connection and just how the circuit's setting and that sort of thing. So it's fine to take the reading. If it varies a little bit, I'm not too worried with this particular circuit. Other circuits will behave better. It's part of dealing with the real world that some things sometimes change. Okay, so I'm going to disconnect that, and what we've got now, we need to move the ammeter from here to this position. Now what I'm going to do is I'm going to remove that wire, and I'm going to remove the ammeter. Now I need to put the ammeter on this side, and what I'm going to do is use this black wire to connect between here and the ammeter. I'm then going to go, so I've gone from here to the ammeter, and I need to go from the ammeter to the bulb. Now you can see the negative side of the ammeter I've connected to the negative side of the battery, and the positive side is going towards the positive. You need to do that, otherwise you will get a negative number on the ammeter. It's not a disaster, but you need to bear in mind that that will happen. Now I've plugged that in, and that is saying 0.362 amps. Now, as I've said, you will get some variation in the current for various properties that we're not going to go into in this video, but they are close enough that we can call them the same. So I'm just going to turn the notifications off. So we can call them the same. So for this circuit, I'm going to say that these two values are the same, plus minus a little bit of kind of variation just to do with the circuit components. So current, same values. Moving on to the next one. Now this circuit, while the ammeters can be, you can kind of bypass, you can't bypass bulbs, so we are going to need another bulb. There we go. So I'm going to put the ammeter in the position for ammeter 1. So we go from the cells, sorry, from the battery to ammeter 1. There we go, from ammeter 1 to the first bulb. There we go. Bulb to the next bulb. This I'm going to use a black wire just to help follow things. And I'm then going to go to the battery. Super. Now, what we've got here, you've got the circuit connected and you can see 0.260 amps. That's dropped 0.259. Somewhere between the two. Nice. Now, I'm going to move the ammeter to the position for ammeter 2. That is between the bulbs. So I need to move one of the bulbs over this way. And I need to connect the ammeter up to that bulb. I need to connect the ammeter up to that bulb. And there we go. 0.260. Now hopefully you'll start to see a pattern here. I'm just going to check we're focusing right. Yes, we are. So with those values, we're starting to see a pattern emerge. Now I'm going to remove that again, connect that lamp up. I'm going to connect the ammeter in the middle here, and there we go, 0.260. So what I want you to do, before I tell you, I want you to think about what the relationship is between all of these values. So just spend 5 seconds having a good think. You can even pause the video if you want a bit longer. Okay, so we can see in this circuit the current was the same in both places, and in this circuit we can see the current was the same in all 3 places. So hopefully conclusion number 1 you can draw, current is the same everywhere in a series circuit. So conclusion 1, current is the same everywhere in a series circuit. And we can see it's a series circuit because there's only one path between the 2 ends of the battery. Now, conclusion 2 is more bulbs, less current. So, more bulbs, less current. Now, some of you might know a technical word that begins with an R that you can use here to replace the word bulbs in that statement, but we're going to come to that later. So, now moving on to parallel 1. For this, I'm just going to dismantle everything because it gets a little bit more complicated here. Now, I'm going to move a little bit more space. So, got my battery pack there, and I've got ammeter 1 in the position for ammeter 1, and I've got 2 bulbs that are going to be in a parallel circuit. So I need to go from the negative side of my battery to a junction bypassing ammeter 4, and the junction is going to be here. Now that junction is then going to connect through to this bulb and go from the junction to the bulb. The bulb is going to bypass ammeter 2 for now to this junction. I'll do with a red wire from here to a junction. That junction is going to connect to ammeter 1. There. and ammeter 1 is going to connect to positive terminal of the battery. Now you can see I've put these the wrong way because you want the positive side of the ammeter to be heading to the positive side of the battery pack, and that bulb will light up. Now I've got a second bulb here that I need to connect, and that is going from the junction here round to the bulb, out of the bulb, back round to this junction. So keeping my colour coding, I'm going to put the black wire on this side. It doesn't matter what the colour of the wires are, they're just to help sort of see how the circuit's working. And just going to shorten this wire a little bit. Go from this lamp to here. So that is our circuit. You see there's that junction there, it's all connected up. So ammeter 1 here is reading 0.702 amps. 0.701 now. Now, if you can think of predictions for ammeter 2, that would be brilliant. Now, what I'm going to do, I'm going to remove ammeter 1 by doing that. So the ammeter, see, the circuit will still work without the ammeter. Remember, it's just an observer. Now, ammeter 2 has to go between the junction and the bulb. So here's the junction, here's the bulb. So obviously it's going to go in the middle somewhere. So what I'm going to do is disconnect the bulb, put the ammeter in place, and connect another wire. So now it's in the middle of that. Well, it's not in the middle of the branch, but it's in the branch. And that is reading 0.345 amps. 0.345. To move to this position, I need to remove the ammeter, so I can remove my extra wire there. Remove the ammeter, reconnect up to that branch, the circuit fires back up. So this position here is this wire over here between this junction and the bulb, so I'm going to remove that. I'm going to connect to there, and I'm going to connect the other side of the ammeter up to the bulb. So this ammeter is also, so is now reading 0.359. 358. There we go. So these two are very, very similar. Now, any predictions for ammeter 4? At this point, some people often predict that it's going to be 0, and some people predict other things. So let's see who is right. Move it up so you can see. So I'm going to remove this ammeter like that, and this ammeter 4 is on this wire, which is this wire here between the the junction and the negative side of the battery. So I'm going to remove that, plug that. So we want the negative side of the ammeter to go into the negative side of the battery. So hands up for 0, hands up for something else. The something else has it, 0.694. Jumping around a little bit. 0.691. 690, that's settled on. So, in our parallel circuit, the current is not the same everywhere, but a plus minus a little bit of that kind of changing I talked about in the circuit. 0.701, 0.690 are very, very similar. So in fact, we're going to call them the same in this circuit. So A1 and A4 are close enough to be the same value. So the current that's coming out of the battery is the same that's going back in. And we say that current goes from plus to minus. So current is going from the plus side, 0.701 lots of it, and the same amount is going back into the battery. It doesn't get used up. So the same amount that leaves is the same amount that comes back. But at this point here at the junction, it's splitting. So that 0.701, half of it, 0.345 is going that way, another half of it, the 0.358, I know they're not exactly half, but they're close enough, So half is going down this way and half is going down that way. Now, something you need to know here, these two bulbs, the two real lamps, are identical. They're electrically exactly the same thing. So your current is splitting equally down those branches. So 0.7 comes out, it splits down the branches, and at this point it joins back up, it adds back up, so you get the same amount at this point. Slightly strange behaviour, but that's what's happening. So let's test our theories now. So we've seen in this circuit, in the parallel one, that the current splits. We've also seen that in this, between these two circuits, the current reduced from 0.346 to 0.259. Now, if you look at these, in this branch, you had one battery, one bulb as a relationship, 0.345. Very similar to one battery, one bulb, 0.364. So very, very similar values. In this circuit down here, again, there's the one battery pack, and you've got two bulbs. So have a look at this circuit. You've got the one battery pack and two bulbs, and think about what these ammeters might read. One bulb, one battery, one bulb, one battery, one bulb, one battery. Think about what this ammeter might read, and think about what these might read. So I'm going to set this up. My first branch is in fact the same, because you've got the bulbs, the batteries coming round, they're going to junctions and to the bulb, here to junctions to the bulb. Super. But what I do need to do is add an extra bulb up at the ends here. And there is said bulb. Didn't need the extra wire. Super. Hopefully you notice this in the other circuits as well. This bulb is much brighter than these two. So in your head, start to think about the current here. So relate that current to the brightness. Now, ammeter 1 over here at the start of the circuit. So it's on this first branch. I'm going to connect this up. 0.563 amps. And hopefully you guys are thinking, right, that is going to have a relationship to this, similar to what it did there. So let's jump straight to A5. Let's see if it is the same. Oh, get the light. Look at that, 0.571. Very, very similar. Some would say the same. So very, very similar. So hopefully you've mapped across the theory from here. Here A1 and A4 were the same. Here A1 and A5 are the same. So that idea that the current going in and out of the battery or out and in of the battery is the same. So A2 here is on this first branch, and it's connected between the bulb and the branch, which is along this part. So disconnect that. Put our ammeter in and connect that up to our bulb, 0.339 amps. Oh, that is very similar to when we had the one battery and one bulb, one battery and one bulb. So 0.364 here, 0.345 here, 0.339 here. So hopefully you're starting to draw that conclusion that in a parallel branch, it doesn't matter about the other branches. If you've got a branch with one bulb and the one battery pack, it doesn't matter if it's in a series or parallel. With these components, you'll always get the same values. Now, the next one, A3, is up at the end there. So A3 is between the junction and the bulb. So connect that in, and that is 0.234. 4. Now up at the top, we made the conclusion that current is the same everywhere in a series circuit. This is a parallel circuit, but along this branch, see there's only one path. There's no junctions between this point getting back to this point. There's no junctions along the way. So if that one's 0.234, hopefully you can draw a conclusion about what this one is going to be. I'm going to remove that, and it is between the two bulbs there. So I'm going to disconnect that one. Put my ammeter here, and connect that in the middle, and 0.229, almost identical to the 0.234. Brilliant. Now this circuit, I'm just going to put it out of the way so that we can focus on our results here. I can even move our camera down so we can see those a bit more clearly, to make sure we can see everything there. So, conclusions we can draw from the bottom ones. The current going into the battery is the same as the current coming out of the battery. Conclusion 3. Current out of battery, same as current into battery. Current splits in a parallel circuit. We've seen that in both of these. I'm going to specify that current splits down parallel branches. Okay, and more specifically, the current going down each branch will add up here. So I'm not going to write that as a conclusion, but we'll keep that as a sort of explanation, because we'll do some problems later or in another video. But you can see the current splits here, but then adds up, so that the current going down these two branches adds back up and you get the same current here. And hopefully that all makes sense. So that is your introduction to current in series and parallel circuits.